Beneath the surface of distant planets lie urgent warning sibilant cries for help that could shatter everything we believe about our solar system. This isn't science fiction, it's a pressing reality. The hidden challenges of artificial intelligence in analyzing planetary surface compositions are right before us, yet most remain oblivious to the risks. Imagine if our understanding of Mars, Venus, or the moons of Jupiter is fundamentally flawed. What if the very tools we depend on to decode these celestial bodies are misinterpreting critical data? This could lead to catastrophic miscalculations. Artificial intelligence is hailed as a game-changer in planetary science, designed to sift through vast amounts of data and detect subtle variations. However, when I encounter surface compositions that defy its logic, it fails to recognize them, leading to potentially dire consequences. Picture this: you're an astronaut on Mars ready to conduct a vital experiment. You check your readings only to find that I has misinterpreted the data, falsely assuring you of safety when danger lurks nearby. The implications are staggering, extending beyond individual missions to threaten our entire understanding of geology across different planets. If we can't trust our eye systems, what does that mean for future explorations? The scientific community is increasingly alarmed as this reality unfolds. As we push closer to the stars, the stakes escalate. What if our probes and rovers overlook crucial signs of life or geological activity? Important missions could be doomed before they even begin. However, there's a glimmer of hope. Scientists are beginning to address these shortcomings, developing new techniques to train eye to better navigate the complexities of alien terrains. But will it be enough? Every time we gaze at the stars, we're not just seeking answers, we're wagering our ability to interpret those signals accurately. The universe is sending us messages, but are we truly listening? As we venture deeper into this cosmic frontier, we must remain vigilant. The implications could reshape our understanding of life beyond Earth. Are we ready to unlock these secrets, or are we merely scratching the surface? Did you know the ground beneath us might be hiding secrets that even I struggles to reveal? Many believe technology is flawless, especially in analyzing planetary surfaces. But what if I told you there are hidden challenges in eye that could shape our understanding of distant worlds? Imagine standing on a barren landscape, gazing at a distant planet. This is just a skiffy dream, it's a reality we're approaching every day. Yet, many don't realize that the tools we rely on to decode these alien terrains may have flaws. Think back to when you used GPS to navigate. If it misread the terrain, you could end up lost or in a risky situation. Now, apply that same idea to analyzing Mars or Europa. What happens if the data is misinterpreted? Hidden challenges arise when models tackle the complex compositions of planetary surfaces. For instance, a misleading analysis of Mars could send future missions off course, leading astronauts to land on the red planet only to discover the eye's predictions were wrong. And what about Jupiter's icy moons? Their enigmatic surfaces mean that misreading them could result in overlooking crucial resources for survival. The stakes are incredibly high, yet many remain blissfully unaware of what's at risk. As these machines learn and adapt, we face a concerning gap in understanding how they interpret information. Are we truly ready to trust their findings, or are we blindly following our high-tech guides into uncharted territory? This uncertainty grows because it doesn't think like we do. It can overlook critical nuances in surface compositions. Imagine relying on a guide who can't see the hidden dangers around you. But there's hope. Researchers recognize these challenges and are actively working to enhance eye's ability to analyze planetary geology. Collaborative efforts between scientists and technologists are underway, ensuring future explorations are supported by reliable data. Still, the question lingers, will we act in time? Will we take these challenges seriously before it's too late? As we continue to gaze at the stars, let's remember that understanding the terrain both here on Earth and beyond is a journey full of surprises. Stay curious, stay informed, and who knows? The next breakthrough could be just around the corner. If you found this intriguing, consider diving deeper into the mysteries of our universe. Imagine standing on the surface of Mars with red dust swirling around you and the weight of untold secrets beneath your feet. But uncovering those secrets is more complicated than we ever imagined. Many people don't realize the hidden challenges I faces when analyzing planetary surfaces. It sounds futuristic, right? Yet, our most advanced technologies struggle in ways that could change everything we know about our solar system. Picture this: a team of scientists sends a rover to explore a distant moon, relying heavily on AI to analyze soil samples and surface features. Exciting, isn't it? But what if the very algorithms designed to unravel these mysteries misinterpret what they find? You might wonder, how can that happen? These AI systems are trained on the landscapes and materials of Earth, which means they might overlook subtle clues hidden in alien terrains. Imagine the consequences if they miss crucial data. Let's dig a little deeper. Think back to the last time you tried to identify a rock in your backyard. You probably compared it to one you recognized. Now, imagine doing that with a billion-year-old piece of Mars. Context is everything, yet our eye struggles when the landscape doesn't match what it's been trained on. And here's where it gets concerning. What if we send a mission to extract resources from an asteroid, only to find that the eye misjudged its surface composition? The risk of disaster isn't just a theory, it's a real possibility. So what's the solution? Some experts suggest a hybrid approach, blending human intuition with the speed of eye. It's not about replacing one with the other, it's about collaboration. Can you see how this partnership could transform our understanding of not just Mars, but all celestial bodies? As we stand on the brink of interplanetary exploration, we must recognize these challenges. The next time you hear about a mission to a distant world, remember the technology we celebrate can also be our greatest blind spot. So what do you think? Are we ready to confront the limits of our own creations? The universe is waiting, and what